For this video, we will discuss the final module of Elementary Physics 1, which is about heat temperature. Let's start with some definitions. Thermal energy represents the total internal energy of an object, the sum of its molecular kinetic and potential energies, while the temperature is the property of a substance that indicates its capacity to transfer or receive heat energy. So how do these two concepts relate to each other? As the temperature of a body increases, the kinetic energy of the structural elements increases as well. As the kinetic energy increases, the body's thermal energy also increases. Therefore, the thermal energy of a certain body increases with the increase of their temperature. So there is a direct relationship between these two concepts. Thermal equilibrium is observed in two bodies when there is no heat flow between them. Usually, ang thermal equilibrium ay evidence sa pagsusukat ng temperature. For example, if you want to know the temperature of a certain object, for example, a cup of coffee, and you stick the thermometer in the coffee, as the two interact, the thermometer becomes hotter and the coffee cools off a little. And after the thermometer settles down to a steady value, you now read the temperature. This means that the system has reached an equilibrium condition, in which the interaction between the thermometer and the cup of coffee causes no further change in the system. So in relation with this thermal equilibrium, the lower fixed point is the temperature at which water and ice coexist in thermal equilibrium under a pressure of 1 atmosphere, while the upper fixed point is the temperature at which water and steam coexist in thermal equilibrium under a pressure of 1 atmosphere. So the lower fixed point has a temperature of 0 degrees Celsius or 273.15 kelvins, while the upper fixed point has a temperature of 373.15 kelvins or 100 degrees Celsius. So, heat is the transfer of thermal energy that is due to a difference of temperature. For example, if you touch a hot stove or meron kang hinawakang kahit anong mainit na bagay, the energy enters your hand because that certain object is warmer than your hand. So for example naman, humawak ka ng yelo, the energy transfers from your hand into the piece of ice. So the direction of spontaneous energy transfer, known as heat, is always from a warmer object to a neighboring cooler object. So from hot to cold lagi. However, remember that matter does not contain heat. What we mean by heat is that it is energy in transit from a body of higher temperature to one of lower temperature, or simply due to temperature difference. Once transferred, the energy ceases to be heat. So, ibig sabihin lang, energy in transit is known as heat. And kapag halimbawa, for example, nakalipat na yung energy from your hand to the piece of ice na hinahawakan mo, that energy is no longer considered as heat kasi nakalipat na siya from your hand into the piece of ice. So how do we measure heat? Or rather, temperature. So a thermometer is used to indicate temperature of an object, and we have several temperature scales that are widely used across the world. In the modern world, we have 4 temperature scales that are used by different countries. So first is the most widely known, which is the degree Celsius or degree centigrade. So it is developed by Anders Celsius and is an arbitrarily assigned the number 0 to the ice point and the number 100 to the steam point. So it is also known as the degree centigrade. So degree Fahrenheit, typically used in countries like United States, it is developed by Gabriel Daniel Fahrenheit, and it is a scale that is based on the choice of different fixed points. So in this scale, 32 degrees Fahrenheit is the freezing point, while 212 degrees Fahrenheit is your boiling point or your steam point. So the next scale is one that is widely used in scientific communities and academic undertakings, which is the Kelvin scale. So the Kelvin is developed by Lord Kelvin, which represents the same change in temperature as the Celsius degree. So, it is also divide. So, kung ano yung itinataas sa Celsius, yun din yung tinataas sa isang Kelvin. However, ang pinagkaiba lang nito is that the absolute zero is equal to 0 Kelvin. And when we convert it into Celsius, that is equivalent to negative 273.15 Kelvin. And last is the degree Rankine. So this scale is developed by William John McCorn Rankine, which represents the same change in temperature as the Fahrenheit degree. The absolute zero in this scale is equals to negative 460 degrees Fahrenheit. So we can think of the four scales in this way. So si Celsius is always related to Kelvin in the manner that their rate of change is the same, and Fahrenheit and Rankine naman yung magamukha din ng rate of change. So that is how we can connect these four scales. So here are some formulas that we can use when changing from one temperature to another. So when we are converting from degrees Celsius or degrees centigrade to degrees Fahrenheit, so we use the formula 9/5 multiplied by the degree centigrade plus 32. And if we want to convert back from Fahrenheit to Celsius, so we reverse this process, and that formula would be given by your degree Fahrenheit minus 32 multiplied by 5/9. So kapag naman degree Celsius to Kelvin, what we simply do is we just add 273.15 Kelvin to the value of your current degree Celsius. And if we want to convert from degree Fahrenheit to degree Rankine, so we just add 460 degree Rankine to your current value of your degree Fahrenheit.
In 1964, the temperature in the Siberian village of Oymyakon reached negative 71 degrees Celsius. What temperature is this on the Fahrenheit scale? So for this problem, you just convert degree Celsius into degree Fahrenheit. So that is 9/5 degree Celsius plus 32 equals negative 95.8 degrees Fahrenheit. For letter B, the highest officially recorded temperature in the continental United States was 134 degrees Fahrenheit in Death Valley, California. What is this temperature on the Celsius scale? So that is 5/9 multiplied by degrees Fahrenheit minus 32 equals 56.7 degrees Celsius.
Thank you for listening. I hope you learned something today, and see you on the next discussion video.